We've already talked about scenario and other what-if analysis, but I thought I would just show a little bit about simulation analysis. And this is just a fun example of what that might look like. So right here we have, and I know that it's very difficult for you to see any of this, and especially when I've got both my laptop screen and the paper, but uh, our base case was 6,000 of unit sales, 80 of price per unit, 60 of variable cost per unit, and 50,000 of fixed cost per year. And you see the lower and upper bounds that were associated with it. Well, what I'm going to do is take each one of these four variables and I'm going to give them a probability distribution. And I'm actually going to have a broader distribution than just these three cases. So what I've done is taken each one of the variables. So for example, we've got unit sales. And unit sales had 6,000 as the base case and only 5,500 as the lower bound and upper bound of 6,500. I've spread that around, so my unit sales go from 5,000 up to 7,000 instead of 5,500 up to 6,500. And I've done the same thing with price per unit. Instead of going from 75 up to 85, I've gone from 70 to 90. I've just spread these around to show more of a worst case scenario than a lower bound. Whether it would be these numbers or not is unimportant for this purpose. Done the same thing for unit sales, variable cost per unit, and fixed cost. And actually with fixed cost I've only gone from the lower bound up to the upper bound. I've associated them with dice rolls. And most of you are probably aware in dice, for 2 dice, there are 36 possible rolls. There's only one way to roll a 2, and that's a 1 on each die. And there's only one way to roll a 12, and that's with a 6 on each die. But a 7, you can roll a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. So there are 6 different ways to roll a 7. And there are a total of 36 ways you can roll the dice, and 6 of them are 7. And 5 of them are 6 or 8, and 4 of them are 5 and 9. And when you go all the way through, there are 36 of them, and 1/6 chance of rolling a 7. And there's 5/36 of a chance of rolling an 8, and 4/36 of a chance of rolling a 9, and so forth. So there are probabilities associated with each one of these. The base case is the one here that's in sort of orange, and that's what I have as sort of the middle case. So what we have is kind of a peaked distribution with the base case in the middle. And I should show over here that the base case had a net income of 23,700. And what I'm showing over here is the whole little balance income statement, just as they did up here at the top of page 354. So I've shown that whole thing, and you see that net income is 23,700, which is what it shows here, and cash flow is 63,700, which is what it shows here, and NPV is 29,624, which is what it shows here. So what I'm going to do, well, give me a second here. I'm going to erase these guys and erase these guys. And these up here. And I have dice over here. I've got blue for unit sales, and I've got green for price per unit, and so forth. So first I'm going to roll my blue dice. And you don't see that, but that's a 3 and a 5, which is 8. And according to this, unit sales, if you roll an 8, would be 6,200. So I'm going to put 6,200 here. And now I'm going to roll for price. And price comes up as another 8. And for price, an 8 would be $82. So far, this is good for me. bigger than average unit and larger than average price. And now I'm going to go to variable cost per unit. It'd be nice if that were low, but we'll see. 5. 5 for variable cost per unit is 58. So I'm going to put a 58 in here. And then I'm going to go down to fixed costs. And for fixed costs, I roll a 7. And a 7 for fixed costs would be 50,000, so I'm going to enter 50,000. And this calculates then a net income of 46,452, a cash flow of 86,452, and an NPV of 111,000. So that's pretty good. Well, that was one try. Let's try a second one. And I rolled a 4, and a 4 is 5,400. 5,400, enter. And then I'm going to roll for price, and I get a 4. And a 4 is 7,400. Sorry, 74. So 74 is my price. That's unfortunate. And now my variable cost per unit. Damn. Rolled a 10, and our variable cost per unit then would be 63. So this is not working out very well for this version. 10 was a 63. And then I roll for fixed costs. Fixed costs, I get another 10, and that would give fixed costs of 53,000. So not so good for this version. So we end up with a negative 151,494 NPV. So that's not so good. But we're going to do this hundreds and even thousands of times. We're not going to use dice. We're going to use a computer, and we're going to set up a probability distribution and a set of values for these different variables, run the simulation, and we're going to end up with a probability distribution of NPVs and IRRs. And we'll probably take a look at what percentage of our cases do we have a positive NPV, and what is the average NPV. And the average NPV is going to come out very close to the NPV for the base case. But we'll see a distribution, and we wouldn't just use this sort of peak distribution for dice. We would use whatever distribution we thought, probability distribution we thought would be most appropriate. And if we felt like, okay, 93% of the cases have positive NPV, and the average NPV is 29,624, we'd probably say, okay, let's do that. Then if we found out that the average was 29,624, but we only had let's just say a 60% chance of having a positive NPV and a 40% chance of negative, we might say, I don't think so. There must be other projects better than this one. So that's just a little play example of simulation analysis.